Now, if we go ahead and talk about this data here, now notice that what we did is we went ahead and showed where the mean and where the median is. There's a couple of things that we also need to go ahead and talk about in general about the shape of the distribution or how the information is distributed. So notice that if, for example, that our mean and our median were basically the same, or if they were equal, then what that would mean then is that there would be a symmetrical distribution of the values of the population. Okay? Now, if, say for example, it is not equal, the mean and the median are not equal, then what we're going to say is that the distribution is skewed. Now, how is it going to be skewed? Well, it's either going to be skewed to the left or to the right, and what we do is we consider that to be negatively skewed or positively skewed. Now, the one thing that we want to go ahead and consider then is if we take a look at this example, notice that the mean is actually less than the median. Since the mean is less than the median, which is this situation here, what we're going to say is that this distribution is negatively skewed. Now, if it were the other way around, where say for example the mean was larger than the median, then we would say that this is positively skewed. Okay, and we can talk a little bit more about this when we get to class. But for right now, let's just go ahead and say that if we have the mean equaling the median, there's a symmetry with regards to the distribution. If it is not equal, then it is skewed. And then you're going to have to compare whether the mean, you're going to have to compare the mean and the median value. Okay? Now there's one last piece that we want to go ahead and discuss as well. And that's with regards to the measure of central tendencies themselves, and in particular with the mean and the median. Now with regard to the mean is actually called a non-resistant measure of central tendency. The reason for that is because if I add a single value, or say for example I don't add, I change a single value, say for example with the values here that I had, like let's say for example instead of having 2 6s there were 2 5s and only 1 6, then just by making that small change, all of a sudden my mean would also change. Therefore what happens then is that the mean is non-resistant to changes to the data. If there are changes to the data, the mean will naturally change. On the flip side of things, if we go ahead and we take a look at the median is called a resistant measure of central tendency. And the reason for that is, say for example, if I change this to a 2 and I change that, and I change this to a 1, the median doesn't change, because really the only value that you're really concerned about are the 2 middle ones. So notice that, or the middle one or the 2 middle ones. In this case, it's the 2 middle ones. So notice that if I do go ahead and change some of the values here, like say for example I change these values here, so long as it wasn't a 5 or a 6, or if I change these 2 values over here to say to something that's bigger than 7, the median would not change, but the mean would. So that's the reason why we call the mean a non-resistant measure of central tendency, whereas we call the median a resistant measure of central tendency. Okay, so that's what we're going to be doing. We're going to be taking a look at the data that we've organized, and we're going to analyze it by looking at the measures of central tendency. Okay, so give it your best shot. Let's see how everybody does, and we'll see if anybody has any questions the next time that we meet in class. Okay, take care. Bye.